Hey guys, welcome back to my implementation series for my rover. Uh, in the last video, we went through points 1, 2, and 3. If you haven't watched that video, I would suggest going and watching that before this one. In this one, we'll go over points 4, 5, and 6. So the motivation for kind of this project was the Fast-LIO2 paper. I wanted to integrate some of the features from that paper into my rover. So that's kind of like the blueprint that I used to uh, kind of figure out which features I'm going to implement in my rover. So the first thing I wanted to do is run the official version of the Fast-LIO2 paper. So I points in point 4, I'm running it in shadow mode in the background. It's not integrated into the nav2 stack, so it's not publishing an ODOM topic which is being consumed by nav2. In point 5, I'm just adding an adapter so that it does get published to the ODOM topic expected by nav2 and gets consumed in the navigation stack. And in point 6, I'm adding some point cloud pre-processing before it's actually consumed by this launch file on the Jetson, right? So we'll talk about those points. Let's start with point 4. So at the beginning, we have this LiveVox ROS driver 2 launch. If you remember from the previous video, I'd mentioned that the LiveVox ROS driver was a prerequisite for this project, so we can kind of just use that and launch this. And this will publish data on the LiveVox IMU and LiveVox LiDAR topics. Then we can look at Fast-LIO shadow launch, right? So the shadow launch, let me just go to the shadow launch file. And if we look at the shadow launch file, essentially it has the main thing it has is these packages from the official Fast-LIO2 implementation. So there's an official implementation. I'll link the GitHub here, which is compatible with the ROS2 that I'm using here. So these packages are coming from that implementation. There's a static transform. Since Fast-LIO expects these custom message formats, I have a small adapter node to convert it into point cloud as well, right? So that's over here, and then that goes into the LiveVox cloud to scan node because that's expecting point cloud input, which does the projection. So we've seen LiveVox cloud to scan earlier as well, right? And then we have this Fast-LIO ODOM being published by this Fast-LIO2 implementation. So it's publishing the odometry on this Fast-LIO ODOM topic. So we went ahead and already ran this this LiveVox ROS driver. So these LiveVox messages are now being published. We can run Fast-LIO shadow launch right here. All right, so now the Fast-LIO ODOM topic should be published. So let's just do a ROS2 topic list. And we can see Fast-LIO ODOM. So if we just kind of echo it, all right, so we see the odometry being published by this Fast-LIO ODOM topic. Again, this is coming from the official Fast-LIO2 implementation, right? Now, if we want to just make this, if we want to integrate this with the nav2 stack, that's what the next point is for. So let me just kind of go down there. So over here, we have this launch file, which is the Fast-LIO2 nav2 launch.py. So essentially, what this launch file is doing is it's taking the Fast-LIO2 ODOM topic, which is being published, and publishing it on and just forwarding it to an ODOM topic, which is going to be consumed by the nav2 stack. So if we go to Fast-LIO nav2 launch, everything is the same except for this adapter at the end, right? So let's look at this adapter. So this adapter is coming from the Fast-LIO2 nav2 adapter package. Under source, you'll see Fast-LIO2 nav2 adapter node.cpp. So if we go in that, the main method is ODOM callback. All right, so ODOM callback gets triggered whenever we get an odometry message from Fast-LIO ODOM, right? So that's the input topic, and the output topic is nav2 ODOM. So uh, over here, ODOM callback gets triggered. We do one thing before forwarding it. We planarize the message. So for instance, there shouldn't be any angular X and Y, right? Because there's no roll or pitch, there's only yaw. There shouldn't be any linear Z because, the rover can't move up or down. So we essentially planarize the orientation and then and we zero out the directions that don't matter, and then we publish in this output nav2 ODOM topic up here, which will be consumed by the nav2 stack, right, on the Pi side. So that's what's happening in this Fast-LIO nav2 launch. It's just integrating the official Fast-LIO2 implementation with the nav2 stack by publishing on the correct ODOM topic. Now, coming down to point 6, right? So in point 6, we have this point cloud pre-process Fast-LIO2 nav2 launch.py. So what's happening there? So the purpose of that is to do some pre-processing on the input LiveVox point clouds. So let's go to that file. Right, so if we go to the point cloud process, this is the file. So again, we're using the Fast-LIO2 packages from the GitHub repo, but we also have this custom Fast-LIO preprocess node over here, right? And if you look at the input topics to LiveVox Cloud to Scan, it's now custom points for nav2, right? So it's not really the same topic. Earlier, we had that adapter between the custom message to point clouds, and we passed in the outputs of that. But here, we're passing in the outputs of the preprocess node for nav2, right? So let's go and check what this node is actually doing, right? So let's do that. So we have custom LIOFast preprocess source preprocess node. Okay, so the main method that I want you guys to focus on is cloud callback. So custom cloud callback. So what custom cloud callback does is it publishes two clouds. It publishes a cloud for odometry, right? And it publishes a cloud for nav2. So first it does some filtering. So this basically gets triggered for every point cloud message. So whenever and this is the custom message format from LiveVox ROS driver, so it's not literally a point cloud format, but it's basically subscribing to LiveVox LiDAR, that topic, and it gets triggered whenever LiveVox LiDAR publishes. And what it does is it does some filtering based on min and max height, range. It does some voxel downsampling. So that's the pre-processing it's doing, and then it essentially publishes to the ODOM cloud and the nav2 cloud. The reason it's publishing to two topics is the nav2 topic, which is custom points for nav2, and the ODOM topic, which is called custom points preprocess. They're used for two different purposes. So custom points preprocess is going to be input to future odometry algorithms. So for instance, we're going to use it for like scan to map registration for the scan to scan ICP, these kinds of algorithms in the future, right? The EKF node and so on, right? The EKF node actually uses a deskewed version of this, but basically the ODOM cloud is used for as input to any odometry algorithms, whereas the nav2 cloud is used as input to the projection from the point cloud to the scan, which is then used in the obstacle layer of nav2, right? So essentially nav2 cloud is used in the obstacle layer of nav2, and the ODOM cloud is used as input to those custom odometry algorithms. So once the filtering is done, so the pre-processing is done for like min and max height, and then the range and voxel downsampling, then these things are published, these clouds are published, and then consumed by the downstream either odometry algorithms or nav2 stack. So that's what's happening over here, right? And then we have the same format as the main Fast-LIO2 launch file we just saw, where we have this Fast-LIO ODOM topic and the nav2 adapter, right? So that's what's happening on the Jetson side, right? So if we go back to the README, yeah, so that's what's happening on the Jetson side. Now let's take a look at what's happening on the Pi. There's a very small kind of change from the previous video where we saw this Pi nav to livevox launch.py, but let's just quickly address that. All right, so in this video, we'll go to what is happening on the Pi, right? So what is happening on the Pi for these points 4, 5, and 6 that we're going over, right? So if you see the main changes in point 4, we use the old launch file that we talked about in the previous implementation video, this Pi nav2 livevox launch. We've been through that launch file already. But at point 5, the launch file changes. We change to Pi Fast-LIO2 nav2 main.launch. Now, why is that? So it's a very tiny change. Basically, if we go to Pi Fast-LIO2 nav2 main.launch, we see that the only thing that's different is this config change right here, right? We're using a different config file right here. So earlier we were using the nav2 params live YAML, where if we go to the ODOM topic is ODOM, whereas over here, when we go to the nav2 params Fast-LIO2 main, the ODOM topic is nav2 ODOM, right? That's the only change. The reason I split them up is because I kind of wanted to split up the base implementation, completely disconnect the base implementation from this Fast-LIO2 official implementation. But that is pretty much the only change between those two launch files. Um, that one has the ODOM topic, the other has the nav2 ODOM topic, and that's the main change. But yeah, so that's what's happening on the Pi side. Right now, let me just show you how this looks like for like a full run, including the points, including the pre-processing and the official Fast-LIO2 algorithm, like integrated into the nav2 stack. All right, for the final part of this video, I want you guys to see what happens when this entire system, points 4, 5, 6, are integrated into the nav2 stack. So essentially, what I'm going to do is run part 6 because that has everything, right? So when I run part 6, so I've just kicked off over here, I've kicked off this ROS2 launch, bring up pre-process Fast-LIO2, and if we look at what's happening here, nav2 ODOM is being published. So I can look at my topic list, and in my topic list, I have all the stuff that I'm expecting. So custom points for nav2 and custom points pre-processed are being published by that custom LIO piece pre-process module that we looked at, right? And then Fast-LIO ODOM is being published by the main Fast-LIO2 implementation, and the nav2 adapters just taking that, planarizing it, and publishing it on nav2 ODOM for our nav2 stack. So this is like all the modules that we discussed, they're working together, and you can kind of see that from this topic list.